Welcome to the video on odd and even functions and inverse functions. So first we'll talk about odd and even functions. An odd function is where f of negative x equals negative f of x. So it'll be equal to each other if you input negative x or if you multiply the whole function by a negative 1. So it has point symmetry about the origin, kind of like your cubic function here, if you just rotated this part 180 degrees. An even function is where f of negative x equals f of x. So if you plug in negative x, it's going to be the same as if you had just plugged in x. So this one will have symmetry about the y-axis. So it would be something like this. So you could reflect it over our y-axis and it would be the same. So next we'll talk about adding odd and even functions. So if you add two even functions, you'll still get an even function. If you add two odd functions, it'll still be an odd function. And if you add an even and an odd function, it won't be even or odd, it'll be neither. When you multiply the functions, if you multiply an even, it'll be even. If you multiply an odd and an odd, it'll still be even. And then if you multiply an even and an odd, that's when it will be an odd function. So here we have three quick examples. So to figure out if they're even or odd, we're going to plug in f of negative x. So this would be 2 times negative x to the fourth minus 3 times negative x squared plus 5. So this gives us 2 times negative x to the fourth is x to the fourth minus 3 times negative x squared is just x squared and then plus 5. So if you look here, these two are the same. So when we input our negative x, it's still the same as f of x. So this function is going to be even. For the second one, we'll plug in our negative x. So we get negative x to the fourth plus 3 times negative x cubed plus 1. So this becomes x to the fourth. This negative x cubed will give you a negative, so it'll be negative 3 times x cubed plus 1. So it's not the same as our original function. And if we pull a negative out, it still won't be the same as our original function. So this is going to be neither. Finally, for this last one, we'll plug in negative x. So we get 2 times negative x cubed minus 3 times negative x. So our 2 times negative x cubed is going to be a negative 2x cubed. So then our negative 3 times a negative x will be a plus 3x. If we pull a negative out from here, we get negative 2x cubed minus 3x. And this here was our original function and multiplied by a negative, so this is going to be an odd function. So that's how you figure out if a function is even or odd. So in a periodic function, it can be even or odd based off of the same rules. So if you plug in the negative x and the output is the same function, then it'll be an even function. And if you plug in negative x and you get negative times the original function, then it's an odd function. So for our trig functions, our odd trig functions would be sine of x, cosecant of x, tangent of x, and cotangent of x. And our even functions would be cosine of x and secant of x. So if we look at our sine function, it looks something like this. So it goes through our origin, and it has symmetry around the origin. So that's why it's odd. Our cosine function, on the other hand, will start at 1 and go down and then back up. So this one, it has symmetry about the y-axis. So that's why this one is an even function. Next, we'll talk about the inverse and self-inverse functions. So to find an inverse, you swap the x and y values and solve for y to get your inverse function. So your new y equals would be your f inverse of x. And the domain must be restricted to where the function is 1 to 1. So each input can only have one output, and each output can only have one input. So for this example, it says find f inverse of f of x equals x minus 2 squared plus 3. So we'll start by swapping our x and y. So we'll have x equals y minus 2 squared plus 3. We'll subtract 3 from both sides. So we have x minus 3 equals y minus 2 squared. Then we'll take the square root of both sides. So this will give us that plus or minus the square root of x minus 3 equals y minus 2. And then we'll add 2 to both sides. So 2 plus or minus the square root of x minus 3 equals y. So this has really given us two functions. So we have f inverse of x can equal 2 plus the square root of x minus 3, or f inverse of x equals 2 minus the square root of x minus 3. So this is going to depend on our domain restriction. Our original quadratic function has been shifted to the right 2 and up 3. So it'll look something like this. So our domain needs to be restricted at x equals 2, because before x equals 2 and after x equals 2, you repeat the same outputs, the same y values. So if we restricted the original domain to x is greater than or equal to 2, then the inverse of that function would be our f inverse of x is 2 minus the square root of x minus 3. Because if we rotated our function here, then the minus part is going to be this bottom half, which corresponds to this right half here. So this would be for x is greater than or equal to 2 for our original one. And then if we restricted our domain to x is less than 2 for our original function, then its inverse would be this first one, because that would be our top portion here, which corresponds to the left side of the original function. So here are the inverses. Our self-inverse function is when the inverse of the function is the same as the function. So our f of x equals x. So here are some examples. It says find the inverses of f of x equals 4 minus x and g of x equals 1 over x. So if we did f of x, that would be 4 minus, and then instead of x, we're going to do f of x again. 4 minus x. So this equals 4 minus 4 plus x, which just equals x. So that means this is going to be a self-inverse function. And you can also do this by swapping our x and y. So we get x equals 4 minus y. You would subtract 4 from each side. So x minus 4 equals negative y. And then if you multiply it by negative 1, you get negative x plus 4 equals y, which is the same as our original function. The same is true for g of x. If we swap our x and y, x equals 1 over y, multiply both sides by y, and you get y times x equals 1, and then divide by x, and you get our g inverse of x is 1 over x. So it's the same as the original function. So our g of x is 1 over x, which equals x. So those are our self-inverse functions. So here we have our first IB practice question where our calculator is allowed. It says, prove that f of x equals 3x squared plus 5 over x squared minus 4 for x is not equal to plus or minus 2 is an even function. So we'll start by plugging in negative x into f of x. So our f of negative x equals 3 times negative x squared plus 5 over negative x squared minus 4. So this equals 3 times negative x squared is just x squared plus 5 over negative x squared is just x squared minus 4. So our f of negative x is equal to our f of x, so this is an even function. So f of negative x equals f of x. Therefore, this is even. Now it says find f inverse of x for one portion of the graph and state the domain restriction. So since we have a calculator, we can go ahead and graph the function. So this is what our function would look like. So here we have our original f of x. So we'll start by finding f inverse of x. So we're going to swap our x and our y. So we get x equals 3y squared plus 5 over y squared minus 4. We can multiply both sides by the denominator and then distribute this x into here. So we get xy squared minus 4x equals 3y squared plus 5. We want both y squared values on the same side, so we'll subtract 3y squared from both sides, and we'll add 4x to both sides. So this gives us negative 3y squared plus xy squared equals 4x plus 5. We can factor the y squared out on the left side, so we have y squared times negative 3 plus x equals 4x plus 5. We'll divide both sides by negative 3 plus x. So y squared equals 4x plus 5, and then we'll swap our order in the denominator and say x minus 3. So y will equal plus or minus the square root of 4x plus 5 over x minus 3. So 4x plus 5 over x minus 3 has to be greater than or equal to 0, so that we don't end up with a negative number inside of the radical. If we multiply by x minus 3 on both sides, the x minus 3 will just go away because it's multiplied by 0. So 4x plus 5 is greater than or equal to 0. Then we'll subtract 5. So 4x is greater than or equal to negative 5. And then we'll divide by 4. So our numerator is positive when x is greater than or equal to negative 5/4. Our denominator is positive or 0 if x minus 3 is greater than or equal to 0. So if x is greater than or equal to 3. So we'll draw a number line with our key points. So we have negative 5/4 and 3. And we're going to have our numerator and our denominator. So our numerator is positive when x is greater than or equal to negative 5/4. So it'll be positive in these two sections and negative over here. And then our denominator is positive if x is greater than or equal to 3. So it'll be positive in this section and negative in these other two. So they're both negative in this first section, and a negative over a negative is a positive. So the inside of our square root will be positive in this section, and then positive over negative is negative. So x cannot equal the values in here, and then positive over positive is positive. So this will be included in our domain. So our domain restriction is that x has to be less than or equal to negative 5/4, or x has to be greater than 3 for our f inverse of x, which is plus or minus the square root of 4x plus 5 over x minus 3. So here's our answer with our restriction on our domain. Now we have our second IB practice question. This one is no calculator. It says f of x equals sine of x and g of x equals x squared minus 2. Determine whether the following would be odd, even, or neither. So f of x, this is our sine of x function. Our sine of x goes through the origin and goes up and then down. So this is going to be an odd function because it has point symmetry about the origin. So this one's odd. For g of x, we'll plug in negative x. So g of negative x equals negative x squared minus 2, which is just x squared minus 2. So our g of x equals our g of negative x. So this one is even. F of x plus g of x is an odd function plus an even function. And we learned earlier that the result of that would be neither. Next, we have f of x times g of x, which is an odd times an even, which will give us an odd function. Then we have f of g of x. So this would be our sine of x squared minus 2, So if we go ahead and plug in negative x, so our f of g of negative x, we can see if it's equal to our original function. So our sine of negative x squared minus 2 is going to equal our sine of x squared minus 2. So this is equal to our original function, so this will be an even function. Finally, we have g of f of x. So this will equal sine of x squared minus 2. So our g of f of negative x equals sine squared of negative x minus 2. So if we took our sine of pi over 6, for example, in this first one, sine of pi over 6 is 1/2. So 1/2 squared is 1/4 minus 2. So this is if x equals pi over 6. So if we put pi over 6 into here, our sine of negative pi over 6 is negative 1/2, but negative 1/2 squared is still 1/4 minus 2. So it appears as though our g of f of x is equal to our g of f of negative x, so this is also going to be an even function. So that's how you would solve these problems. So in summary, our odd function has point symmetry about the origin and is when f of negative x equals negative f of x. Our even function has symmetry about the y-axis, and our f of negative x equals f of x. When adding odd or even functions, our even plus even equals even, odd plus odd equals odd, and even plus odd equals neither. When multiplying, even times even is an even function, odd times odd is even, and even times odd is odd. Our odd periodic functions are sine of x, cosecant of x, tangent of x, and cotangent of x. And our even periodic functions are cosine of x and secant of x. To find the inverse of a function, you'll swap the x and y and then solve for y to get the inverse function. The domain must be restricted to where the function is 1-to-1, and our self-inverse function is where the inverse is the same as the original function. That's all for this video. Thank you for watching.